So today's GFG problem of the day is allocate minimum pages. So this is a very famous problem based on binary search. So okay, I've solved the problem. So we'll first go through the problem statement and then the explanation and then the code, of course. So okay, the problem statement states that we have been given few number of books and their pages. So like book 1 has 12 pages, book 2 has 34, and book 3 has 67 pages, book 4 has 90 pages. Okay, and we have to distribute or allocate these books to few number of students. Okay, so what we have to do is every student needs to get at least one book. Okay, and we can only allocate these in a contiguous fashion. That means that I cannot say that to student, suppose student 1 I give 12, I give the first two books. Okay, now to student 2 I gave 60 this third book. Now I cannot give this book to student 1 again. Okay, because this won't be in a contiguous fashion. So what I want is it should be in a contiguous fashion. So if I'm giving to student, if I want to give third book to student 1, it should be in this fashion, that all of these books should go to student 1. Okay, we cannot break this sequence. Okay, and no book should be assigned to more than one student. Of course, like we cannot distribute the same book to two students. The same book cannot go to two of the students. Okay, so how to approach this? Okay, the objective here is that however we distribute, the maximum number of pages assigned to any student should be minimum. Now how do you understand this? Wait, I'll suppose, let's say that the current number of students is 4, for example, or let's say current number of students is 3. So suppose you have to distribute these 4 books among 3 students. Okay, so what possibilities are, what are the possibilities? So one possibility is, um, one possibility is that you give first book to student 1, you give second book to student 2, and you give both of the third and the fourth books to student 3, because we cannot leave any book. And we give both of these books to student 3. Okay, now this person, basically student 1 has got 12 pages, student 2 has got 34 pages, student 3 has got 157 pages. Okay, so what is the maximum number of pages assigned to any student? 157, right? 157 is the maximum of pages assigned to student 3. Now a second scenario can be where we give both, basically the first and the second books to student 1, the third book to student 2, and the fourth book to student 3. In this scenario, what is the maximum number of pages given to any student? For student 1, it is 36, 67, 90. So the maximum given is 90. Okay. Similarly, there can be another scenario where student 1 has gotten the first book, student 2 will get the second and the third books, and student 3 will get the last book. In this, what is the maximum number of uh, pages, or maximum number of pages, yes, given to any student? 7 plus 4, 13, and 10. 7 plus 4, 11, and 10, so 101. No, this will be the maximum. Okay, whatever. So this is the minimum. So we have minimized the maximum number of pages assigned to any student via this. Okay, in this scenario. So this will be our answer. Now I have taken k is equal to 3 in the question. K is equal to 4 is given. So I think you've understood the meaning of the question, that we need to minimize this maximum number of pages given to any student. Okay. Now, now how to approach this? So basically, in here, if you think, more about the problem statement, there is a particular range within which our answer will lie. Okay. So, what do you think is the lowest possible number of pages which will be assigned to any student? Now, you can have, suppose if you have four students, basically if the number of students is equal to the number of books, and you have to give each student a book, so each student will get one book. Student 1 will have this, student 2 will have this, student 3 will have this, student 4 will have this. Now, what is the maximum number of pages given to any student under this scenario? 90, right? So this is the minimum value of the possible range of answers. Okay, 90. What is the maximum possible value? If you had just one student, if there was only one student, no matter how many number of books are there, you have to assign all of the books to student 1, right? So the summation of all of these values, I think they will sum up to 203. I am not sure, and I am not worried about the summation, but the summation of this array will give you the maximum possible range. Okay. So whatever our answer is, that will lie within this range. Okay, whatever our answer is, that will be within this range. Yeah. So so this is the possible range. Okay, now what we have to do is for each every particular value. Suppose I am at, so in this condition the answer is 113. Okay, let's say, okay, I'll start with the lowest possible. Suppose I am at 90. Okay. Now at 90, what I want to check, suppose this I am putting as that this should be the maximum number of pages assigned to any student. Okay. And I have three students, student 1, student 2, and student 3. So what I'm doing is, suppose I'll assign the pages to students now one by one. Okay. Now can I give book 1 to student 1? Yes. Why? Because the maximum 90 will allow me to give 12 to one student. So I'll give 12. Can I give 34 to student 1? Yes. Why? Because if I add up these number of pages, it will still be less than 90. So it allows me to give this book to student 1. Can I give 67? No, because as soon as I add up 67 in here, it will exceed. Now, right now I am working for 90. Okay, so I only want to check if 90 is possible. Okay, so I won't give 90 to give the third book to student 1. Now I can assign this third book to the next student. I cannot give the fourth book to student 2 because otherwise it will exceed that 90. And now to student 3 I am giving this book. Okay. Okay, there were only two students, right, in the problem statement. So there are only two statements. Sorry, there are only two students. So we will take care of only two students. So yeah, now I cannot give the fourth book to student 2. So I am left with one book, right? So the allocation was possible only to two students. That's why 90 will not be our answer. Similarly, we'll check for 91, 92, 93, and henceforth. So now we will reach 113. Now, how does 113 play out? So I have two students again, student 1, student 2. So for student 1, I try to assign 12. So I can assign. Then I try to assign 34. Assign or allocate the second book as well to student 1. So I can assign that. Now, if I try to assign 67, will that allow me 67 plus 34 plus? Yes, we can, because still 113 is the minimum. Okay. We are not exceeding it. We cannot exceed that. That's the only criteria. Okay. And for student 2, I have 90. So the number of students we to whom we have assigned the the books, they are equal to the given number of students in the question, and all the books have been allocated, so no books are left. So this is a valid answer, and since we want the minimum answer, we'll stop as soon as I get the as soon as I get this value, the minimum value. Okay, since we're starting from low and we are moving up to the high. Okay. Now, this is the brute force approach, basically a linear approach. So, okay, I had coded the linear approach as well, but let's talk about binary search as well. So, as I told you, the answer lies within a particular range. The answer lies between this to a maximum value, okay, which is the sum of all the pages in the array. Now, in binary search, what we do is we pick up a pivot, which is a middle element. So, in here, I pick up the middle element and I try to find if that number of pages are is if it is possible to allocate those number of pages to the given number of students. If it is possible, suppose this number was 100 and suppose the number is 120. If it is possible to assign this, okay, what we will do is, see, we want the minimum possible, right? It is possible to assign this. So what we'll do is we'll reduce our window and we'll search only in this area. We have reduced our window and now the next search will be within this area. So from here we will take a pivot. But if it is not possible to assign even 120, which means we have to basically increase the number of pages, right? So we will take this part of the window. Okay. So yeah, I think explanation is pretty much clear. So now we can go to the code. So okay, I'm finding out the basically in this min of max pages and max of max pages is the range. So min of max pages will be the maximum possible value present in the array and maximum will be the summation. Now in the brute force, what I did was I traversed from this range, suppose 90 to the summation, and for each of the value, for each of the number of pages, I was trying to find the number of students using a function which will go through. And if that number is equal to the number of students, it means that it is possible to assign that way. That will be our answer. Okay. In binary search, we have simply changed this logic and we are finding the mid value, and based on the possibility, we are reducing the size of our window. Okay, so this part is pretty much clear. I think this part is easy. So let's talk about the function. So in this function, I am taking some pages and I'm trying to allocate the students. I'm trying to find the number of students between which I can easily divide these pages. Okay, so uh, yeah, I think we are not using this. Yes. So, okay, let's take one example here as well. So it was 12, 34, 67, 90. This is our ARR and pages. Let's take 113 for example, or let's take 90 for example. Okay, and we are taking one student. So what I'm seeing is, uh, I try to assign this to student 1. Can I assign? Yes, I can assign. Current value is 0. Current number of pages is 0. 0 plus 12, 12 is less than equal to 90. So I can assign, right? So what I do is I increment. I add, basically I say that okay, 12 pages have been assigned to student 1. 12 pages have been assigned. Okay. Now again I is incremented. Now we are at 34. So can I assign 12 plus 34? Is 12 plus 34 less than 90? Yes. Yes. So now student 1 has got 12 plus 34 number of pages. Okay. Now again I is incremented. We are at 67. Is this summation plus 67 less than equal to 90? No. So we cannot assign. We cannot assign. If we cannot assign, we will go to else. Student count is now increased to 2. So basically we have moved to the second student. Okay. And now this current value will be at 67. Next iteration, we are at 90. Can we add 67 and 90 up? No, because that will be of course greater than 90. So we have to increase student count to 3. So basically we are taking more students as the number of students possible. So if it is greater, if the number of students are greater, of course we have to reduce our window, right? Now suppose, let's just take another example. For if we have 113 pages, then what we are doing is student count is 1. Okay, and in here basically this part will be same, but here this number of pages has changed. So we can now assign 67 to this student. Now we cannot assign 90. Okay, so the student count will stay at 2, because for the second student we can assign this book, the fourth book, and for the first student, these three books will work. Okay. If you need more understanding with respect to the code, you can dry run it, but the solution will work. I have submitted the code, so yes, that's all.